Hello everyone, I am Lalit Sharma from the Venkateshwar School, Gurugram. Today we will discuss the concept of electromagnetic induction. In our last topic we discussed what is magnetic flux. Now we will discuss the phenomena of electromagnetic induction. What is it? So you have studied in your 10th class also about basics of this electromagnetic induction in the magnetic effects of current chapter. Now we will discuss this topic in detail. As the name indicates, electromagnetic induction means if magnetic field is there, we can produce electric current. We can induce electric current. As we all know that current has magnetic field, means if current is there, magnetic field is induced, magnetic field is produced. So here by changing magnetic field, we can produce current also, the reverse situation. So what is the electromagnetic induction? It is the phenomena of generating current or EMF in a circuit by changing magnetic field linked with it. If you are having a circuit, if you are having a coil, and if you change the magnetic field linked with it like this, if you are having this coil and it is connected with this galvanometer, say this is the galvanometer, this is coil, and if you are having a magnet and these are the north and south pole of magnet, if you bring this magnet close to this coil or then away to the coil, means the relative motion is there between coil and magnet, so magnetic field is ultimately changing. So due to change in this magnetic field linked with this coil, galvanometer shows a deflection, means the indication of electric current in this coil. So this is the phenomena of electromagnetic induction. So if we talk about what we call the EMF induced, so EMF developed in the circuit is known as induced EMF, and the current in turns, if EMF is there, we know current is there, so current is known as induced current. So this is the concept of electromagnetic induction. Students, on this phenomena, Michael Faraday performed some experiments to show how we can induce current in the coil, and we will discuss those experiments in detail in some other chapter. Michael Faraday performed experiments to show how we can induce current in a given circuit. We will discuss those experiments in some other lecture. Here we will state what are the Faraday laws. So Faraday proposed two laws basically in case of electromagnetic induction, and the first law states that whenever magnetic flux linked with a coil changes, if you are having this coil and magnetic flux is linked with it and the magnetic flux is changing, EMF is induced, and this EMF induced lasts so long as the change in magnetic flux continues. Means if we stop the change in the magnetic flux, EMF will not induce. So EMF is induced as long as change is there. So magnetic flux presence is not sufficient, it should change for induction of EMF. So this is the first law of Faraday. Means if you are if I recall this law, so whenever magnetic flux linked with the coil changes, an EMF is induced in the circuit, and this EMF lasts so long as the change in magnetic flux continues. So if we talk about second law, it is the further explanation of, you can say, first law. As we know, first law tells that whenever magnetic flux linked with the coil changes, EMF is induced. This law states that how much value of EMF will be there due to change in the magnetic flux. So it tells the magnitude of induced EMF in the circuit is directly proportional to the rate of change of magnetic flux linked with it. Means faster the magnetic flux is changing, larger the value of induced EMF. And if you have slow rate of change of magnetic flux, then EMF will be less. So this law tells how much EMF is induced, and this first law tells EMF is induced in the two laws given by Faraday in the explanation of electromagnetic induction. In our next lecture, we will discuss mathematical formulation for this second law. Thank you.